Now let us see that how the cloud computing has evolved over the time. What were the other technologies and drivers and factors which took to the evolution of cloud computing? So there was little bit history and market drivers. So if you see that history, in the beginning there used to be grid computing and internet service provider ISP companies. So they took little bit of, they were responsible for building the initial block for cloud computing. In the technology area, there were virtualization, Web 2.0, converged or mashup, open source. So these were the things which were starting in the technology drivers area. Economic drivers were the cost for scale was a very big demanding factor. Lot of people were coming up with the ideas where they do not have upfront cost and they just wanted to pay as much they needed. A startup and time to market was another reason why cloud computing got a big push from this thing. Now let us see some of these evolutions in little detail. So grid to cloud. So what happens is that earlier it was a grid computing which was solving large problems with parallel computing. So it was a parallel computing, but the data was at the same place and it was mostly used by a large company, not everyone or a small company, small people, individual people, mid-sized company. They were not able to utilize this grid computing because it was too expensive to start and complete any task. Now there was a utility company computing which started. It started in late 1990s and that formed a kind of a base for the SaaS computing. So this is where the cloud computing started. Okay, SaaS, software as a service. So what happened is that software as a service like Yahoo, Google, Google Calendar, all are software as a service. Okay, Google Calendar, Yahoo Photos, all of them are software as a service. Now when they started, it kind of built the possibility of a cloud computing where next generation internet computing and next generation data center started, where they not only started giving SaaS but also infrastructure as a service as a part of cloud computing. So this was the evolution of cloud computing from grid computing to utility computing to SaaS computing to cloud computing, that is IaaS, PaaS and SaaS. Okay. Now let us see grid versus cloud. What is exactly is the difference between grid computing and cloud computing? It can become very confusing sometimes. So first underlying concept is that both are utility computing. So depending on how much you use, you can pay. Main benefit of grid computing is solves computationally very complex problems. So the whole infrastructure was done in a way that unless the problem or challenge is very big, it was not of much benefit. But cloud provides a scalable standard environment for network-centric application for development, testing and deployment of any kind of application. It doesn't have to be very complex problem. Now grid computing in resource and distribution, it was like you negotiate with the company, manage the resource sharing. There is some scheduler when you want to use, when you don't want to use, when can you use, when you cannot use. There were timeline and slots given to you. But in cloud, it is a very simple user provider model, pay per use. There is a very much easy mechanism to utilize the resources. Grid computing was almost non-commercial and publicly funded and was only for large company. Cloud computing became very commercial and a player, even the smallest player and largest player, both can play in the cloud computing. So this is the ISP to cloud, how it happened. Web 2.0 changes. So Web 2.0 changes concentrate on the private user and clouds are descendants of data center which service the enterprise. So 2.0 brought the lot of new technologies in the software development cycle itself. So a lot of new Web 2.0 technology which came, whether it was Java server pages or C# or struts, Hibernate, Spring, lot of new technology started coming up in which people started promoting software as a service instead of developing a off-the-shelf software product. So the focus earlier was developing a software product, but slowly that became, don't develop a software product and sell it on a CD. Put it on a website and use the latest technology which gives the very nice interactive animated look and feel and experience, which was earlier only possible for the non-internet based application. So new Web 2.0 technologies gave a good momentum to develop applications which are software as a service. And then later these Web 2.0 companies, when they started creating a product which was provided as a SaaS service, they had a scale problem as well. So now this scale problem also pushed this company to look for some low cost, cheaper alternative instead of buying high CPU, large number of servers for themselves. In fact, today user-centric Web 2.0 companies like Twitter and SlideShare are relying heavily on cloud service. So Web 2.0 changes also was responsible for evolution of cloud computing. Now let us see about what are the economic and time to market drivers for cloud computing. Time to market forces developers to use third-party components and platforms. So whenever there is a pressure to do the time to market, people look for outsourcing some of the things and focusing on the core business. So what they started doing is that let us use a third-party components, platforms, infrastructure, everything, network bandwidth, and outsource all of this work and try to focus just on the core new business value which we are providing. So that also kind of triggered a need of cloud computing based infrastructure. It was cheaper, it was better, it was scaling. So because it scaled cheaper, because you need from one server to two server to three server only when you need it, and when you don't need it, you don't have to pay for three server, you can come back and you can pay just for one server. So that's what it says. So the storage, servers and CPU all were very great from economics of scale. And it was pay as you go, so it was nobody need to put lot of money ahead. The other changes which took place was Web Services and SOA. Web Services and SOA let the people develop the infrastructure and applications in the cloud so that other applications which are inside a company or which are traditional and legacy applications, they can integrate and interact with the cloud computing applications. And that was possible because Web Services and SOA as a technology had evolved and got very matured. There was a demand for obviously mass scalability and rapid user growth. Standards like API, SOAP, REST and SAML were all evolving, so they also gave a push to this one. And one of the most important was virtualization, which let this cloud computing company create an infrastructure where the same CPU, RAM and hard disk can be used by multiple peoples and can be released and acquired these resources irrespective of who other person is using that system. Converged and mass-up solutions like HP, they also came up with new ideas and concepts that if cloud computing as a service is provided by multiple vendors, then how a customer can use and manage the services from more than one cloud computing vendors. So that also gave another push to cloud computing adoption, because now people were not worried that if I have two different cloud computing solutions from two different vendors, will there be a problem? Because of various solutions provided by HP, that is no more a problem. The networks became faster, so all of this. Now we'll understand that what is virtualization. In this session, virtualization is a concept where using the software you can make the hardware from multiple computers look like as a pool of big computer resource. Now what does exactly mean? Let us see that. So before that, let us go into traditional server. What is the basic concept of traditional server? You have an application, you have some hardware. On that hardware you have some operating system, some storage, and there is some application running. So let us assume that this is a web server. It has a web server, Windows is the operating system, and IIS is the another server. Now what we will see is that let us have another server which is application server, operating system is Linux, and Glassfish is the web server. Okay. Now let us have another server which is again Linux, which is a database based server and DB server, and it uses MySQL. This is an email service which is based on Windows and uses Exchange. So we have seen this is Windows based IIS web server, Linux based Glassfish application server, Linux based MySQL database server. So I have 4 servers. One is a web server, other is a app server, third is a database server, fourth is a email server. Now if something goes wrong, let us assume that this guy goes wrong. If this guy goes wrong, then what do? Now what you will have to do is that you will have to find another server which just looks like this and try to replace it. Now if you have 2 or 3, then another problem happens is that let us assume I have a backup server. So if I have a backup server, just because redundant there, until it crashes, this whole server, another backup server just sits idle, and it is a wastage of resource. So you cannot just solve this problem in a most efficient way unless you have something like cloud computing. So the traditional server benefit is that it is easy to conceptualize, fairly easy to monitor, easy to personalize the security part. Virtually any application or service can be run from this type of setup. But there are disadvantages. First disadvantage is allocated functionality wise. So what happens is that for each functionality you have allocated one server. But it is quite possible that maybe out of 2 or 3 of them are underutilized completely, and one is overutilized or heavily utilized, which you cannot solve the problem because you cannot break the CPU and RAM into very low granularity. Second is that it is expensive to acquire and maintain hardware upfront for all of them, and they are not easily scalable, because let us assume you have a 20 computer and you need to scale. You will first have to order 20 computers. You have to decide, figure out, order the computers, bring it them, install and set up, and then do it, all of that. But in cloud computing you will see that scalability is the first thing which is solved very easily, and within seconds or minutes you will be able to scale without any problem. Now what is the formal definition for a virtualization? Formal definition is that the term virtualization broadly describes the separation of a resource or request for a service from the underlying physical delivery of that service. For example, VMware or virtual machine. Traditional servers, let us revisit this one. So it has a single operating system per machine. Software and hardware are tightly coupled. Okay. Running multiple applications on same machine often creates conflict. Underutilized resources. So when you are running that particular business software, it is useful. Otherwise, the rest of the time, 90% of your RAM, CPU, and hard disk is just sitting idle. It is inflexible and costly infrastructure. So this is what it looks like. You have a computer which has a CPU, which has a memory, which has a network interface card, which has a hard disk. And is x86, it has an operating system, and there are multiple applications here. Okay. Now in the virtualization, what happens is that this is what it was before. Okay. Now in the after mode, what happens that you have still the same hardware, but there is an interesting this layer called VMware virtualization layer. Now this has single CPU, single memory card, single network card, single disk, but it can create a two virtual computer with the hardware representation. So it has now created two computer, each with its own RAM, CPU, hard disk, etc. So now there are two representation of hardware. So both of them can have their own operating system like this, and on top of that you can have the application. So that is the benefit of virtualization. Hardware independence of operating system and application. Virtual machine can be provisioned to any system, can manage OS and application as a single unit by encapsulating them into virtual machines. Now what is the benefit of virtualization? First benefit is server consolidation and containment, test and development optimization, business continuity, enterprise desktop. A virtual server can be serviced by one or more hosts, and one host may house more than one virtual server. The virtualization is based on a partitioning techniques, and partitioning techniques are of also various type, but we will skip this one. So hosted architecture, in this one it is based on the installs and run an OS application. This is based on bare metal hypervisor architecture. This is little advanced of partitioning techniques, so we'll just skip this one. So this is the way it looks like. So you may have a lot of storage, lot of network card, lot of RAM, lot of CPU boxes, and you can represent it as a common shared pool of hardware. And on that hardware you can install 3 system, 5 system, 2 system, 1 system. It is all up to you. So this is called virtualization of large number of resources. So all these resources have been virtualized, and he can use 1 CPU, he can use 2 CPU, he can use 3 CPU whenever they need. When they don't need it, they can use it. So it is completely virtualized. And there are a lot of softwares involved into that one. So this is what cloud infrastructure looks like in terms of virtualization. So there it is, virtualization summaries are pros and cons. Okay. This completes our virtualization and basic introduction to cloud computing. We'll go into a little bit more deep inside cloud computing in next session.